Okay, so for today, I decided to have our lecture on a asynchronous discussion. So I'll be discussing your terminologies or introduction to your architecture structure or the design of reinforced concrete structure. So last week, I already orient you na pagsasama-samahin ko yung classes of CEAS, CERC, and CESD. It is because we are dealing with the same ano lang naman course, which is the design of reinforced concrete structures. So for today, I decided to have our as asynchronous discussion so that you can review this on your own pace, or you can analyze and study your lecture at your own. So by the way, anyway, these are just common terminologies now. So that pagka na-encounter natin to on our next discussion, familiar na tayo, no? And meron na tayong initial knowledge regarding these topics. Okay? So let's start with the structural members. So the first one is the column. So yung column is a member with the ratio of height to the least lateral dimension of at least or 3 or greater. This is used primarily to support actual compressive load. So yung column natin, ito yung ating mga vertical member. Wait lang. I will fix my pen. Let's see. Okay, sige. But I'll change the color lang. I think. Okay? So yung column natin, these are your vertical members. Alam niyo naman yung mga poste. That is column. Meron tayong mga poste. And nagre-receive to ng axial compressive load. Usually, but of course, yan, parang hindi na masyado. Okay. Again, yung ating mga columns, vertical yan, tapos nagre-receive yan ng axial compressive load coming from the beam. But also, yung column natin, nagre-resist yan ng mga lateral forces caused by your earthquake or your wind load. So, meron naman tayong mga lateral members, which are your beam. So, lagi, this is your beam. For example, this is your concrete beam. So, ang mga nare-resist niyan, yung mga loadings natin, no? Vertical loadings natin. Usually, these vertical loadings are transferred from your slab. Then, kung kinukuha natin yung loads na transfer niya to our columns naman. So, yung beams natin can be classified as singly reinforced, doubly reinforced, deep beams, and T-beams. So, for the singly reinforced, kapag ka-reinforced concrete tayo, concrete yung beam natin, but our reinforcement is on the side of the tension lang. So, tatandaan natin, either the top or the bottom is your tension side. Kapag ka nasa support tayo, our tension side, sa support to, nasa support, our tension side is at the top. Pagka nasa bottom tayo, ang tension side natin ay nasa bottom. Pagka nasa mid-span tayo. So, sabihin kung single reinforce siya, yung reinforcement natin, the required reinforcement is at one side lang. Doon lang siya sa side ng tension. However, because of the specification of the codes, hindi naman pwede na ang beam natin ganito lang. Meron tayong beam, meron tayong stirrups na tinatawag, meron tayong, ito yung reinforcements natin. Hindi naman pwede na wala tayong wala tayong reinforcement sa other side. So, naglalagay pa tayo ng reinforcement, at least 2. Para yung stirrup natin o yung tinatawag na anilyo, meron siyang pagkakapitan. Di ba makikita niyo sa construction nakapalibot, nakapaikot, or dun nilalak sa tinatawag natin na main bars. So, pagka singly, ito actually, for ano lang to, Support lang siya doon sa ating stirrups. Pero ang important sa atin is yung mga reinforcement sa tension. While sa doubly, pagka doubly naman ang beam natin, both of the side of the compression and the tension is dinedesign natin yung reinforcement. It is because sometimes we are limited, nililimit natin yung height ng beam natin. For example, kailangan kasi natin ng huge view ng window. Hindi naman pwede na ang beam natin is more than 500 millimeters, di ba? Masyadong malaki yung kalahating metro. Eh, kailangan natin ng view or kailangan natin malaking mga bintana, di ba? So, kailangan natin i-decrease yung height ng beam natin para maabot natin yung ceiling height na, na gusto natin, especially for the architects, di ba? Gusto natin minsan yung yung height ng ating building or ng space natin, kung ano yung height na specified natin, iyon yung mangyayari. So, pagka ganong cases na hindi siya kaya ng beam, i-adjust natin yung height ng beam. So, mag-a-add tayo ng compression. Kasi yung concrete natin ang compression. Dahil babawasan natin yung size ng concrete, kailangan maglagay tayo ng compression bars. So, dinedesign natin both the compression bars and the tension bars. Yung mga deep beams naman, ito yung mga beams na masyadong malalalim. So, 500 millimeters, more than 800 millimeters, yun yung height ng beam natin. So, yun yung... So, T-beams naman, it is called T-beam kasi yung beam natin is in a shape of T. Yan, T-beams talaga siya. So, meron tayong flange at meron tayong web. So, yung reinforcement na to, either reinforced din siya sa tension side lang or reinforced din siya sa compression side. So, ganun yung T-beam. So, yung wall is actually nowadays, we are not considering walls as structural members. It is because we can no longer trust the strength of our CHB so that yung walls natin, hindi natin siya kinoconsider as structural member. Instead, yung walls natin, ginagamit na lang natin siya to enclose spaces, no? Separate spaces. Mas ma-separate natin yung room, ma-divide natin yung ating building. So, gagamit tayo ng walls. Pero kaya ang ginagawa na natin ngayon, mostly framed yung structure natin na binibuild muna yung columns and beams together, connecting to one another. Then yung walls, yung division natin, huli na siya. So, hindi siya part of the structural members. Okay? Next are the slab. Slab natin, ito yung mga shallow na beam. Tinitreat natin to as beams din. Pero, syempre, dahil shallow siya, no? And wide. Wide yung kanyang width, pero shallow yung depth niya. So, that is your slab. So, sa slab po, ito yung mainly nagre-receive ng loads natin kasi siyempre yung tao, yung live load, dead load natin, nire-receive natin sa slab. Tapos yung beam niya, nandito, nakasupport dito yung beam. Tapos kay beam, nakapatong si beam kay column. So yung slab talaga natin, yung main nagre-receive ng loadings natin. Tina-transfer na lang natin yan at tina-transfer. So, meron tayong two classification of slab, the one-way slab and the two-way slab. Kapag one-way slab, usually these are slab, makikita nyo sa plano, no? Yung mga slab na ganito yung itsura. Ang division niya, ganyan lang, vertical. Kasi yung transfer of load natin sa one-way, papunta siya sa longer side. Kasi yung bending natin happens on the shorter side. Siguro most of you would think, bakit ang nagbe-bend sa one-way slab is yung shorter side? Kasi usually isipin natin, dapat mas magbe-bend o magkakaroon ng deflection sa longer side kasi mas mahaba yun. But no, on a one-way slab, yung ating deflection occurs on the shorter side of our slab. It is not far from the concept of your what do you call it, your folding bed. As you observe, pagka may humiga sa folding bed, yung sag ng folding bed, hindi naman siya doon sa longer side eh. Kundi yung sag ng folding bed, kung ito yung folding bed, magsasag siya. Pagka may humiga dyan, magsasag siya doon sa shorter side. So, ganun yung concept ng ating one-way slab. Para siyang folding bed. So, kaya ang sinusupport natin, ang kinosolve natin for a one-way slab is the reinforcement along your shorter leg. Along the shorter leg. Yun yung ating sinusolve, yung reinforcement natin sa shorter leg. So, sa two-way and yung ratio pala, usually, yung ratio ng shorter side sa longer side, so shorter side to longer side, that is less than 0.5. So, pagka two-way naman, ito yung minsan nakikita nyo, pagka nakadrawing siya, nakaganyan sa plano. Or sometimes, naggagawa ng 45 degrees to ha, triangle. Yan, yung ganyan. Yan yung two-way. Kasi both ng sides natin makaka-experience ng deflection. The shorter and the longer side may experience deflection. So, two-way yan. Kung ma-differentiate naman natin siya, pagka two-way yung slab natin, the ratio of your shorter leg to the longer leg is greater than or equal to 0.5. Pagka 0.5 na or greater, that is already a two-way slab. So, next is the footing. Yung footing usually we are not seeing the footing kasi ito yung mga nasa foundations na natin. So, footing natin, meron tayong wall footing. Ito yung footing na nilalagay natin sa wall, sa ilalim ng wall natin to support yung walls natin. Meron tayong isolated footing. Pagka isolated footing, for example, ito yung beams, ito yung framing natin. May mga columns dito, columns to. These are columns. Kapag ka-isolated footing tayo, each one, meron silang footing. Kada isang column, isang footing. So, yan yung isolated. Kapag ka-mat footing naman, usually, the whole building itself is under a mat footing. Ito yung mga ginagamit sa mga high-rise structures, mga mega structures such as yung ating mga malls, yung mga highly loaded na structures. Kasi ginagawa natin na mat footing kasi meron tayong tendency kapag ka bumibigat yung structure natin over the years, nako-compact yung soil natin and nagkakaroon tayo ng settlement. Pero yung settlement na yon hindi siya dapat malaki. So, centimeters of settlement is enough na. Pero pagka nagkaroon ka ng meters of settlement o lumubog yung structure mo in meters, medyo may problema tayo sa lupa. Pero kaya tayo nagma-mat footing so that pagka nagkaroon tayo ng settlement, for example, this is your building. Tapos naka-mat footing yan. Since naka-mat footing tayo, pag nag-settlement tayo dito sa baba o lumubog yung isang part, hahatakin yung kabilang part so that stable pa rin yung structure natin habang nagsisettlement siya. Unlike kasi sa combined footing, kapag ka lumubog yung side na to, maiiwan yung other side. So nagkakaroon na tayo ng cracking sa ating mga structural members. So kaya sa mga highly loaded structures, ang ginagamit natin is mat footing and high-rise building as well. So pagka combined or isolated footing naman, na-miss ko pala yung combined footing. Isolated footing, mapapansin nyo, nagkakabit tayo ng tie beam. Yung tie beam naman, ginagamit yun para yung beams natin, para siyang tinalian. Kaya siya tie beam. Tatalian natin yung structure natin. So that pagka nagka-settlement tayo, since isolated yung footing natin, hindi sila sabay-sabay magsisettle. So yung tie beam, dahil nakatali sila together using your tie beam, wala silang choice. Kundi pag nag-settle yung isa, magsisettle din lahat. So for the combined footing naman pala, okay na tayo sa mat footing, no? For example, Sometimes kasi nangyayari, pag kunyari nagkaroon ako ng CR dito, lalagyan ko ng poste dito. So, sobrang liit ng distance between and mag-overlap yung dalawang footing kapag ka nagkadalawang isolated footing ako. Hindi naman pwede na may footing ako dito tapos meron akong footing na nasa ilalim. No. Instead, ang ginagawa natin, nagkakaroon na tayo ng isang footing na meron siyang dalawang columns. So, yun yung ginagawa natin. That is the combined footing. Yung nakikita natin na may dalawang columns sa isang footing, that is a combined footing. So, piles naman is a different thing. Usually, piles are used in bridges. So, yung mga nakasoak into water or yung mga high-rise building din and structure kasi yung mga piles natin, dinidrill to towards the bedrock. So, yung piles natin inaabot, yung dinidrill natin, yung mga pilote, yung mga pencil na sinasabi nila. So, dinidrill yan hanggang maabot niya yung bedrock o yung pinakamatigas na part ng lupa. At doon, kasi ginagawa sa piling, tinutusok siya sa lupa. Kapag kaya pa siyang hugutin or malambot pa yung lupa o sa siya drinil, isasagad pa siya until maabot niya yung part na parang naka-incorporate na siya sa bedrock. Hindi na siya kayang kuhanin or hugutin pa. Okay, that is your piles. So these are some terminologies in reinforced concrete. So the reinforced concrete is concrete reinforced with no less than the minimum amount required. It can be pre-stressed or non-pre-stressed and designed on the assumption that the two materials act together in resisting forces. So reinforced concrete natin, this is simply your concrete with reinforcement. So yung reinforcement na nilalagay natin sa concrete natin shall not be less than the minimum amount required. So kapag sinolve natin that this is the minimum reinforcement, so we shall follow that, no? So yung usually yung reinforced natin na alam is steel reinforcement or steel bars. Yun yung mga reinforcement natin. But some we can also use pre-stressed tensions or post-tension cables as our reinforcement. Hindi laging bakal yung reinforcement natin. Sometimes we use tension rods, we use cables. So, what is concrete? Concrete is a mixture of Portland cement or hydraulic cement, fine aggregates, coarse aggregates, and water with or without admixture. Sa main component ng concrete natin, yung main na nakukuha natin, the cement, no? Kailangan natin ng cement for our concrete. The fine aggregates are all or the sand. The coarse aggregates are the gravel. Then water, of course. It will not be a concrete without the water. Okay? Kapag ka mixture lang ng cement, for example, cement plus water, ang tawag dyan ay paste. Iyan yung cement paste natin. Diba? Pagka meron siyang cement, sand, and water. Sand, cement, and water. That is your what? Mortar. Okay? That is your mortar. So usually sa mga CHB, yung palaman sa CHB, that is mortar. Pagka meron ng sand, gravel, water, and cement, that is your concrete mixture na. So, with or without, yung admixture, it is optional for us. But sometimes, we add admixture to increase the strength of our concrete. Sometimes, we add admixture to speed up the curing period para mabilis natin ma-reach or mabilis matuyo depending on the need. For example, sa road repair natin, kailangan mag-open kagad yung road natin. So, we need admixture kasi nagkakaroon siya ng malaking abala kapag hindi kagad natutuyo. So, if we need to wait for 28 days curing period, malaking abala na yon. So, that we add admixture para reach the concrete yung full potential or full strength niya even before 28 days. So we add admixture for that. So we also have plain concrete. So the plain concrete is concrete with no reinforcement. So it does not conform to the definition of reinforced concrete. The concrete mixture itself, that is your plain concrete. So we also have precast concrete. The precast concrete naman, ito yung mga concrete na ino-order natin. These are concrete na hindi natin siya kinas or hindi natin ginawa dun sa site of our construction. Instead, in-order natin siya, then ipupwesto na lang natin siya dun sa ating structure. Sometimes we have precast walls, as you observe dun sa new Saya building, mga precast walls na ginamit doon. So, ginawa yon elsewhere, then pwesto na lang siya doon sa pwesto niya sa building. So, now we have innovations of lightweight concrete. Kasi nga, tendency sa concrete, mabigat siya. So, even its own weight, dinadala siya ng building. No? Yung sariling weight ng building, nakakadagdag sa kanya. So, nagiging, ano ngayon yung lightweight concrete. So, sa lightweight concrete, dapat ito ay may weighs na 1,900 kilogram per cubic meter. So, ang ginagamit natin, of course, para magka-lightweight concrete, lightweight sand or yung mga mixture or elements of a concrete dapat lightweight. Okay? So what is cement? Cement is our binding agent for concrete. Kung walang cement, hindi magmi-mix together yung ating gravel and sand. So imagine niyo yung gravel and sand may tubig. So yun lang yun. Pag cement, walang binding agent. So sa aggregates, these are granular materials, can be a sand, a gravel, or crushed stone, and iron blast furnace for slab, used with cementing medium or concrete from concrete or mortar. So yung mga fine aggregates natin, this is our sand. Kung alam niyo yung sieve, ito yung ginagamit sa soil analysis, about 6 millimeter in size. Kapag ka nag-pass through dun siya sa sieve number 4, fine yun, sand yun. Pagka hindi siya lumusot, that is already gravel. Okay? So for our aggregates, ginagamit natin, especially for coarse aggregate, no? Sometimes, 1/5 no form natin. For example, this is your form. Yung shorter side, 1/5 nito, dapat iyon yung size. Para sa slab, dapat 1/3 ng thickness ng slab, 1/3 nito. It is because hindi naman pwede na slab mo tapos yung aggregate mo mas malaki pa sa slab mo. So it is not possible. Dapat mas maliit siya siyempre. Aggregate siya. Hindi naman alam yung slab mo may bako-bako. So hindi siya possible. So pagka sa beams naman or columns, 3/4 of the minimum clear spacing. For example, this is your mga bakal mo. So, ito yung spacing. Clear spacing, so parang side to side. Yung 3/4 ng isang side, yun yung maximum size of your aggregate. So, lightweight aggregate, these are aggregate with dry, loose weight of 1,100 kilogram per cubic meter or less. So, like, for the concrete, sabi ko kanina, for us to achieve a lightweight concrete, dapat lightweight yung ating aggregate. Okay? So, the water, yung water na ginagamit natin in mixing in concrete shall be clean, free from injurious materials such as oil, acids, alkalis, salt, organic materials, or other substances that may be deteriorated. Yung water natin dapat clean. Bakit meron tayong specification that it has no salt and acid? It's not a salted water kasi sometimes, of course, yung concrete natin, meron tayong reinforcement, there are substances na pwedeng mag-cause ng oxidation or kalawang dun sa ating reinforcement. So, we want to avoid that para maiwasan natin na mag-deteriorate yung ating reinforcement. Diba? Pag na-deteriorate yung ating reinforcement, pwedeng mabawasan yung integrity ng ating structure and it also cause failure. Okay? Next is what is admixture. Admixture are the materials other than water, aggregate, or cement, which are the main components of our concrete. Other than that, that is already admixture. Okay? So, Yan. We use admixture as an additional ingredient so that ma-modify natin yung properties ng concrete. Of course, on a better purpose, pwedeng, paabilisin ng curing, sabi ko kanina, pataasin pa yung strength. So, in our concrete, our basis of observing the strength of our concrete is the compressive strength of concrete or F prime Z. Always take note na kapag meron tayong ganitong notation na prime, that is represent compression. Okay? So, yung compressive strength natin is always expressed in megapascals. So, ayan, ginagamit siya in designing. Sometimes it is given, sometimes it is depending on the class of our mixture. So, meron tayo mga classes of concrete. We usually have class C, B, we also have A, double A, triple A, and 4A. So, usually familiar lang tayo sa C, B, A, and double A. So, yung A kasi, double A is a top or structural, mixture of concrete. Yung C, ginagamit lang natin yan sa mga plain lang na, hindi siya structural members or not even sa road, no? Itong C and B, pang plant box lang yan. So, I don't want naman to see you designing plant box. Though, you may, but sana hindi tayo malimit sa mga plant box. No? Kasi kahit ano mangyari dyan, matibag man yan, wala naman tayong pananagutan. So, for A, ito yung mga ginagamit natin na sa structures. So, nag-start tayo sa A ng 20.7 megapascals, 21, tapos 28 megapascals, then 35 megapascals, and 42 megapascals. So, kung hindi stated yung ating compressive strength, we can observe baka stated anong type of mixture siya so that we can identify what is our F prime of C. Okay, the metal reinforcement. So, metal reinforcement shall be deformed. Ayan. So, usually, ang ginagamit natin metal reinforcement are deformed bars. Yung deformed bars, di ko sinabi na may sira or kundi yung may mga kanal-kanal, nakikita nyo yun, yung may ganyan, may mga kanal-kanal. So that are deformed parts. So that yung binding ng metal and ng concrete ay matibay. Kaya dapat deform yung bars natin. Unless sinabi na pwede tayong gumamit ng plain. Pero usually kasi kapag plain ang reinforcement natin, madulas siya. So, ginagamit lang natin yung plain for architectural features. Okay? So, yun. The next is the plain reinforcement. So, basta wala siyang deform, ginagamit natin ito usually for architectural features, mga grills, mga gano'n. So, wala siyang, so, deform, yung reinforcing bars, bar mats. So, na-explain ko na rin siya. Okay? So, spiral, meron tayong column na spiral. So, pag circular yung column natin, makikita nyo yun pagka ginagawa pa lang, no? Makikita nyo naka-spiral yung ating reinforcement. So, that are spiral reinforcement. Of course, para yung mold or yung design ng ating structural member ma-maintain. So, sa stirrups, ito, alam nyo to, pag stirrups, nagre-resist siya ng shear and torsion. Kapag sa beam, yung tinatawag nating anilyo, that is your stirrups. Kapag for the beam yun, beam. And pagka tie naman yung tinawag, ito yung sa column. Tie ang tawag natin sa column. Again, beam for the stirrups for beams and ties for column. Pero pareho lang sila na same purpose. It is to hold our main reinforcements. So, anchorage, these are post-tensioning device. No, ginagamit natin sa mga post-tension. Pagka makikita natin sa yung mga parang anchor, yung mga, kunyari may tension tayo. Kasi pagka tension rod, hinahatak yun eh. Pag post tension, hinahatak siya. Tapos yung panghatak, that is your anchorage. Tendons, ito naman yung mga cable and wire na ginagamit natin sa precast concretes. So, tendons yung ginagamit natin doon. Banded tendons, simple lang. Pag yung tendon natin, 2 or more, pinagsama-sama natin, that is banded tendons. The development length, these are the length of the embedded reinforcement. So these are the length that requires the development of the reinforcement. Again, of course, nagkaka-experience tayo ng tension or pwede mag-elongate yung ating reinforcement. So we allow allowances for the development. So it's the effective depth of a section. For example, this is our beam. This is our reinforcement. So the effective depth is from the midspan of our reinforcement to the compression fiber. That is your effective depth. Embedment length, this is the length of embedment of reinforcement. So laging may minimum required embedment length, no? So hindi pwedeng lumulutang yung ating reinforcement sa concrete natin. So dapat embedded siya on a certain embedment length. So we have the forces and loadings. Yung loads natin, ito yung mga critical for the engineers. We have to determine all possible loads. Kung maaari nga, sobra pa sa capacity ng building. Para so that kung sumobra man, so, sinabi natin na 100 kilos lang, dapat ang design mo for 120. So there are cases na hindi mo naman lagi monitored na 100 kilos lang ang load na ipapasok sa structure. So we have to be prepared. So for the dead load, yung dead load natin, these are loads na hindi gumagalaw. Yun yung basically. These are fixtures, the structure itself is the dead load, yung mga structural members, beams, columns, dead load yan. Hindi lumilipat ng lugar. Yung mga fixtures natin, dead load yan. Okay? While the live load, ito yung nag-iiba in magnitude and position. Yung tao, live load yan, pwedeng minsan magaan, minsan mabigat, minsan nasa left, minsan nasa right. Lumilipat siya ng posisyon. And sometimes, it could also be wind. Kasi yung wind natin, live load yan. Sometimes, meron tayong malakas na hangin, mahinang hangin. It could also be rain. Yung volume of rain natin, hindi pare-pareho. Yung earthquake natin, hindi pare-pareho ang magnitude and or intensity. Okay? So, yung lateral loads naman natin, these are loads on horizontal direction, lateral. So, it can be wind or earthquake. So, factored load, like I said, kung 100 kilograms ang capacity natin, nagkakaroon tayo ng factor. So that, meron tayong parang multiplier na ginagamit para mapataas natin yung loadings natin. So that, diba, mas malaki yung kinoconsider natin na load. Modulus of elasticity, ito yung ratio ng strain to stress. Diba? That is modulus of elasticity. Meron tayong tensile stresses and compressive stresses. So for concrete, ito yung formula for the modulus of elasticity. But for reinforcements or metal, usually we use 200,000 megapascals as a modulus of elasticity. Okay. I forgot to, kapag live load pala natin, when it is moving at own power, like your cars, that is already, it is a live load, but it is more often called as moving loads. Okay? Types of design, meron tayong tinatawag na ultimate strength design. Ito yung may mga ginagamit tayong reduction factor, and usually ito yung ginagamit natin in design, the ultimate strength design. Pag nominal, kung ano lang yung weight, for example, 100 kilogram, that's it. That is your nominal. Pagka meron tayong multiplier, that is your ultimate. The required strength, this is your, for example, you are solving to design a building that can carry a 2,000 kilonewton per square meter of load. So that is your required load, required strength. That your building has to carry a 2,000 kilonewton per square meter of load. So yung required strength is a 2,000 kilonewton per square meter. So composite concrete flexural member. Sometimes our concrete can be composite. It is connected with a steel and a concrete. So here. So I think that would be all for our introduction. I guess medyo mabilis ako magsalita, but sana na-gets ko siya. Anyway, you can ulit-ulitin yung pag-replay. And I also uploaded this module so that on next week, we will have your synchronous examination at 1 o'clock. Okay. So, sige. That would be the end. So, thank you for listening.